Hello, boys and girls. Welcome to Science and Daily Life. I am Sir Zamin.
And I am Miss Freeman.
I do hope that you are well prepared today as we continue electricity and look at conversion of energy.
Now, boys and girls, our objective for today is to identify ways in which energy can be converted. Now, let us start with hydroelectric generators. Now, why would we talk about hydroelectric generators? The reason why we want to start with hydroelectric generators is to simply show you in which energy or electricity can be converted from one form to another. Have you ever heard about the Maka hydroelectric plant in the Rupununi area? It is a typical hydroelectric plant. What really happens is that a large dam is built across a river to hold back the flow of water. The water is then released through special control gates. The flowing water turns the turbine, which then turns a generator to produce electricity. Here you can take a look, boys and girls, what a hydroelectric plant looks like. You can see there's a water reservoir, water filter, or there's a flow of water there. There's a dam. There's a flow control gate in which we allow the water to pass. There's also an electric generator and a turbine wheel. At the end of it, there is a downstream that you can see the arrow is showing where the water flows. This is just a simple example to show you what an electric plant or a hydroelectric plant looks like.
Now, boys and girls, if you could have recalled in your previous lesson, we looked at ways in which electricity can be produced. And one such way is by electromagnetic induction. So here in the hydroelectric generator, we see how electricity is being produced. All right? Now, boys and girls, let us look at the energy conversion through the hydroelectric plant. We first have the potential energy of water, which is a stored energy found in the dam. When we allow the water to flow, that potential energy is being converted into kinetic energy. When that water turns the turbine, that kinetic energy is now being converted into mechanical energy. When that turbine would start to turn, that mechanical energy would now be converted into electrical energy. So if you can look at your screen, we have here a flow chart to show you potential energy of water to kinetic energy of water, then to mechanical energy of turbine, and lastly, we have our electrical energy.
Now, another way in which energy can be converted to one form to another is from the nuclear energy to electricity. Now, the energy within the nucleus of an atom is called nuclear energy. By a suitable method, this energy can be released. In a nuclear power plant, some of the nuclear energy becomes heat energy, which can boil water to produce steam. The steam drives a turbine, which in turn is used to run a generator. This nuclear energy is converted to give us electrical energy.
Now, boys and girls, although there is no nuclear-powered electrical plant in Guyana, there are many in other parts of the world. As humans use up more and more of the other fuels, such as coal and natural gas, they will turn more to other alternative power to generate electricity, such as the nuclear energy. Now, let us look at a flow chart of how nuclear energy is being converted into electrical energy, rather. From nuclear energy, we have heat energy, then to mechanical energy, and finally, electrical energy. Ms. Riemann?
Good. Now, so at the end of it all, what we're trying to say is that electrical energy is produced from one form to another. We're getting all the energy being transferred. Now, another way in which we can look at is solar cells. And boys and girls, you have been exposed to solar electricity around you. Can you name of 2 items in which we can use solar energy or solar electricity to power any device or so that you have around you? I know for sure we have some buildings are equipped with solar panels that are then used to produce electricity in that home or maybe the building itself. Now, some calculators also use solar energy. Have you ever seen a solar cell in a calculator? There are some that has little bars on top of them that you have to put in the sun to recharge. Yes, a solar cell converts light energy from the sun into electrical energy. Solar cell requires no moving parts, so they do not wear out quickly. Many artificial satellites orbiting the Earth are powered by solar cells.
However, there is a disadvantage of using solar cells. The disadvantage of using solar cells is that they produce electricity only when light is shining on them. However, the electrical energy is normally stored in special batteries. For example, the Oriella Health System on the Corentyne River is powered entirely by a solar cell system consisting of a series of solar panels, batteries to store the electrical energy, and an inverter to convert the direct current from the batteries to alternating current for household use.
So we can definitely say Oriella Health Center runs on solar panels or solar electricity.
No need for GPL bills there.
Yes, so boys and girls, I do urge you to take a look at the video which we have prepared for you. Do enjoy!
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator which produces electricity when the turbine spins. There are 2 main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
enjoy that video on hydropower and on energy conversions. Now I need you to take a look at the image in which we have here. Can you help us identify some of the energy transformation that's occurring? First, we have an ice cream. Do you think when you eat that ice cream, it's in the form of chemical energy? What do you think we will use that chemical energy to do? It'll give us motion, or will allow us to move. So it's transfer from chemical energy to moving energy or to motion.
Next, we have radiant energy, which comes from the sun. Now, the plants students also utilize this energy. It converts the radiant energy into chemical energy so the plant would carry out its daily activity. For example, photosynthesis.
Here you can also see a symbol of a gas station or a gas pump and a car. So we use the chemical energy or the fuel that is in that gas pump to give us motion or give the vehicle motion. You also have their electrical energy where you can see the little plug and the point, and it will give us thermal energy. There's some, for example, the electric kettle. It will use electrical energy to give us heat. Now, boys and girls, today we talked a little bit about hydroelectric generators, and we talk a little bit more on energy conversion. And we simply showed you that energy can be converted from one form to another, and from energy to heat, light, from light to energy, to electrical, and so on. Do join us again for another lesson in Science in Daily Life. I am Miss Raymond.
And I am Sir Zamin.
Bye-bye.